So in this video, I've got 3 exercises for you to calculate. So one is to show that the logarithm of cosec of theta minus the cotangent of theta is equal to minus the logarithm of the modulus, of course, of the cosec of theta plus the cotangent of theta. And this is a sort of easy identity to remember. There's either a minus sign here or there is a minus sign here. Second identity is the cosec of 2 theta plus the cotangent of 2 theta reduces beautifully to the cotangent of theta. And then finally, we have this exercise. The sum of these 2 logarithms reduces to minus the logarithm of 1 minus sine theta. So have a go at trying to show them with pen and paper, and then come back and I will go through full solutions and make a few comments. So I will see you in a few minutes. Okay, welcome back. Let's look at the first exercise on the next slide. So for this exercise, I'm actually going to start by telling you where it arises. The integral of cosec of theta with respect to theta is the log of the modulus of cosec of theta minus the cotangent of theta plus a constant, or you can rewrite it as minus the natural log of the modulus of cosec of theta plus cotangent of theta plus a constant. So from the rules for logarithms, this identity tells us that this and this, the arguments of the logarithms, must be reciprocals of each other. So 1 over that must be the same as this or vice versa. Because there is a modulus sign, it is possible that there could be a minus sign here and brackets around it, so that it might be that this is equal to minus cosec plus cotangent, but this is actually the way it works out, but if not, we'd find it. So I'm going to start on the left-hand side where they're in the denominator, because I think it might be easier to combine things and play with things and see what happens. So rewriting this in terms of the definitions of cosecant and cotangent, we have 1 over sine theta plus cos theta over sine theta, cosec, cotangent. This looks horrible. It's really ugly. And I really want the denominator not to involve the sum of fractions. So it's very natural to multiply the top and the bottom by sine theta to get rid of these over sine theta terms here. So in the numerator, we get sine theta, 1 times sine theta. And in the denominator, we get 1, we get rid of that sine theta on the bottom, plus cos theta, we get rid of the sine theta on the bottom. So we obtain this. Okay, that looks much nicer than that. Now, here we have 1 plus cos theta, and that might make you think about things like 1 minus cos squared theta is sine squared. But to get that, we have to multiply here by 1 minus cos theta. 1 plus cos theta times 1 minus cos theta is 1 minus cos squared theta. And that's fine, we can get that, but we have to multiply the bottom by this factor, and we have to also multiply the top by the factor. So all we're doing is taking this and multiplying it by 1. It's an algebraic identity. So remember, this is what we started with. This is what this is. And we've now seen it's equal to sine theta, and we're multiplying the top by 1 minus cos theta, and we're multiplying the denominator by 1 minus cos theta. And the reason we do that is because when we multiply it, we'll get 1 times 1, we'll get plus times minus, so minus cos squared theta, and the cross terms cancel. So now, we have this. The bottom can be rewritten as sine squared theta. So the difficult thing about this was we had a sum of 2 terms in the denominator, and now we've only got 1 term in the denominator. That's likely to help us a lot. I haven't changed the numerator yet. And part of the reason for not doing that, apart from not doing too many things at once, is that we see now that we can cancel a sine theta in the top with one of the two powers in the denominator. So what we are left with is 1 minus cos theta divided by sine theta. So this is now two terms. It's 1 over sine theta and it's minus cos theta over sine theta. But that is cosec and that is cotangent. So the thing we're starting with, 1 over cosec theta plus cot theta, we see is equal to cosec theta minus cotangent of theta. And that is what we wanted to show. So what are the important algebraic steps? Well, one is having, I think, a great distaste for things that look like that. It's ugly, so you want to multiply top and bottom by sine theta to get rid of these fractions in the denominator. And the other thing is wanting to simplify the denominator if we can. And if you've got 1 plus a, if you multiply it by 1 minus a, you'll get 1 minus a squared. And in particular here, you're going to get 1 minus cos squared, and that reduces to sine squared. So it's just this central identity, cos squared plus sine squared is 1, coming to the rescue again. And then after that, it was just a matter of tidying up the algebra, breaking it into the difference of two terms, and identifying the reciprocal trigonometric functions. So with that, let's look at the second exercise. So in our second exercise, we want to show that the sum of the cosecant of 2 theta and the cotangent of 2 theta reduces to the cotangent of theta. And we're going to clearly need to use the double angle formulae. So the cosecant of 2 theta is 1 over the sine of 2 theta. The cotangent of 2 theta is 1 over tangent of 2 theta. So it's cosine of 2 theta divided by sine of 2 theta. So they have a common denominator, so we have 1 plus cos of 2 theta divided by sine of 2 theta. Let's look at the denominator first. The formula for the sine of 2 theta is 2 sine theta cos theta. For the cosine of 2 theta in the numerator, I know 3 different ways of writing it. One is cos squared theta minus sine squared theta. One is 1 minus 2 sine squared theta. And the third version is to write it as 2 cos squared theta minus 1. These all follow from cos squared theta minus sine squared theta, the central version of it, and using cos squared theta plus sine squared theta is 1. Okay, you can use any one of these 3 versions and the numerator will simplify to the same thing. And I'd encourage you to try putting in all 3 versions here and seeing it work. But the simplest one is to say, if I write cos of 2 theta as 2 cos squared theta minus 1, I'll cancel that 1. So the 1 and the minus 1 here are going to cancel. So now let's just rewrite this. The numerator is 2 cos squared theta. The denominator is 2 sine theta cos theta. So again, we have a cancellation. The factor of 2, top and bottom, will cancel. And in the numerator, we have got 2 powers of the cosine. In the denominator, we have 1 power of the cosine. So therefore, the cosine squared will partly cancel with the cosine in the denominator. So we are left with our result for cosec of 2 theta plus the cotangent of 2 theta. It's equal to cos theta, 1 power of cosine here, divided by sine theta, and that is just the cotangent. So that is the result that was quoted at the front, and that's our answer for it. So the key identities in this question that we needed were to know the formulae for the double angle, functions like sine of 2 theta and cosine of 2 theta, and then it really follows automatically. Okay, with that, let's go on to the third identity. So the third identity is the sum of two logarithms, and I think it seems fairly natural to try to put the two of them together using the rules for logarithms. So log of a plus log of b is log of a times b. So that's a, that's b, and since a is sec theta, the product is just multiplying both terms by sec theta. This becomes sec squared theta, and then plus, and then it's sec times tan. So what we have is the logarithm of 1 over cosine squared theta, that's what sec squared theta means, plus, and then sec times tan is 1 over cos times sine over cos, so the numerator is sine and the denominator is 2 factors of cosine, cos squared theta. Because these terms have the same denominator, we just put them on that common denominator, 1 plus sine theta over cos squared theta. And now, when we see this, we again think this is very much like the first exercise, that cos squared theta can be rewritten as 1 minus sine squared theta, so as to turn everything into sines, and then 1 minus sine squared theta factorizes using one of our favourite relationships. 1 minus sine squared theta is 1 plus sine theta times 1 minus sine theta. This should really be at the tip of your fingers. This sort of algebra comes with practice. So if we rewrite this in this way here, we see that the 1 plus sine theta, top and bottom, will cancel, leaving us with a 1 in the numerator. And the denominator is 1 minus sine theta. So we have the logarithm of 1 over 1 minus sine theta. That's 1 minus sine theta to the power of minus 1. And therefore we just take the power in front. And we say that our result for this that we've been calculating is equal to minus, that's taking the power of minus 1 out, the logarithm of 1 minus sine theta. And with that, we have finished proving the final identity. So I hope this has been fun to go through and that it's helped you feel happier rearranging such trigonometric formulae.